In this lesson, we're going to talk about similar polygons and what that means. So the definition of a similar polygon is when polygons have the same overall shape, but they're going to be different sizes. So my best example for that is clip art. So you know how you take clip art, you can click in the bottom right-hand corner and you can drag it. So those two original figures, like I have drawn here, so figure 1 and figure 2, it's the same picture, just different sizes. So two things that we really need to notice. One is that the corresponding angles are congruent. Okay, so just because the house on the right is 3 times the size of the house on the left, it doesn't mean that the angles are changing. So like these 90-degree angles here in my windows don't all of a sudden become 270 degrees when I enlarge it, right? Those angles are still congruent. Okay? So that's important to recognize. The second part is all the corresponding sides are proportional. So if I again go from it tripled in size, you know, if this was 1 inch tall, now this is going to be 3 inches tall. If this is, let's say, 2 inches, this is going to be 6 inches, and so on. Okay, that's going to be true for every side length. So let's just start with, are the shapes similar? So we're going to start up here at the triangles. Okay, because they are isosceles, we can determine those base angles. Right, we can determine that each base angle is 70. Okay, so they are going to be similar because we have all the angles that are the same. When it comes to, so let me write yes there. When it comes to the rectangles here, my sides are not proportional because if I compare 2 to 2, that's in a ratio of 1. But then if I compare 2 to 5, that's not in a ratio of to 1, or the ratio of 1. And then finally, the last set, my angles are not going to be congruent, right? Or at least they're not marked congruent, and they don't look congruent either. So these are not similar. Naming similar figures, in this case triangles, works the exact same way as congruent triangles. So remember how we were labeling, like we had to label what corresponded with angle A, or what corresponded with angle B, and then C. So in our similarity statement, we can do a triangle here. We have triangle ABC. This is a symbol here for similar. It's just the tilde. So ABC is similar to triangle. And now because A had 1 tick mark, D also has 1 tick mark, so I had to label it D. And then B has 2 tick marks, so E has 2 tick marks. And then finally F. So triangle ABC is similar to triangle DEF. In this one, we're just going to talk about scale factor. So we do have similar triangles here because they are equilateral. Okay, so we know then all the side lengths and angle measures. All right, so now the scale factor is a comparison. Okay, it's a comparison of corresponding sides. So in our case here, it's a factor of 8 to 16, but that can be reduced in a factor of 1 to 2. Now, typically they list scale factors either going left to right or top to bottom. If they don't want it in that order, they typically say list this triangle compared to the other triangle. So usually go left to right or top to bottom. All right, so let's take a look at this. We're first going to figure out the scale factor. So it says quadrilateral ABCD is similar to JKLM. Complete each statement. So I like to go through and mark my angles, so I just have a little bit of point of reference. So I know L and C are going to be lined up, which is kind of obvious here. Okay, according to my statement, angle B and angle K are going to be congruent. So I'm going to mark those. And then finally, A and J are congruent. Okay, and I have this angle D is 70 degrees. That means angle M must also be 70 degrees. All right, so we need to compare corresponding sides in order to get our scale factor. So if I start with the left figure, I see I have a 6. So KL would have to correspond with BC, but I don't have a measure for BC. So let's try a different side. I see that LM is 15, all right, and that should compare with DC, which is 20. So my scale factor is 15 to 20, or I can reduce that by dividing by 5 and I get 3/4 or 3 to 4. So you can write it as a fraction, you can write it as a ratio, it doesn't really matter. But that's the scale factor that I'm going to use to solve, I'm going to use it as a proportion to help solve for side BC, JM, and JK. All right, so 3/4 is my first fraction I'm going to use, is equivalent to BC I want to solve for. So BC over here, BC right here, I'm going to solve for BC. Oops, I grabbed the wrong thing there. Here we go. BC should correspond to KL. Okay, so the 3 is for the left figure, the 4 is for the right figure. So I need to be consistent. So I'm going to do 6 over BC or X, whatever you'd like to call it. So I have 3 times BC is equal to 24. So BC is going to be equal to 8. All right, let's do another one. Let's solve for JM. So again, I'm going to start with 3 over 4 equals. Okay, so I want to solve for JM. That's this side here. It corresponds to the 28. So I'm going to solve for JM over 28. Now the other thing you could do is recognize 4 times 20 or times 7 is 28. So I really need to take 3 times 7 and I'll get 21. So I know JM is equal to 21. And then finally JK. All right, so JK here, let's see if I can find another color. JK corresponds with AB over here. So my fraction looks like 3/4 equals, it's going to be JK over 12. So again, you can cross multiply or you can look at the pattern. This is times 3. So this would also be times 3. So 3 times 3 gives me 9. So JK is equal to 9. All right, for this assignment, what you're going to be doing is you're going to go into Google Slides. I have it posted on Google Classroom. But in Google Slides, there are 4 slides, and each slide has a different set of instructions. So make sure you read the instructions. Most of it is a drag and drop. There's one like circle what's false and then correct the statement. But 4 slides, when you're done with that, turn that in.